putting the two things together today, we're going to end up by finding the gradient and using differentiation to do it. So what we were doing on Friday, for those of you who weren't here and those of you who were, is we were looking at a graph. Let's say it's this one. I'm going to say that this graph is y equals, starting again, don't like that one. Y equals x squared plus 3. All right, that's what that graph is going to be. We learned to draw the gradient function of that graph. What did we do? We did not. We straight line things. We took the turning point and dropped it down to the x-axis. Then we looked at the gradient and said it is negative, 0, positive. So it's going to turn around being negative, 0, positive. So that's the gradient function. That process of drawing that is very likely to be in the exam, and that is very likely to be an easy U mark. What is the relationship between these though? So what happens if I differentiate this? What do I get?
2x.
Not y, but yes.
dy over dx.
I get 2x. The 3 goes away, and we take the power and multiply by it. If I had said to you, what is the equation of this red line? Hopefully most of you could have said it's a y equals x because it's a straight line, and the gradient is approximately 2 up and 1 across. So you would have got y equals 2x plus 0 because it went through 0. Y equals 2x mx plus c, right? So you possibly, most of you could have got that that was the equation of that red line. That is the equation of the gradient, and that gradient function came from the original function by differentiating. All right? So what happens is that that red line tells us that down here, this point here has a gradient of approximately negative something or other, 4 perhaps. And here the gradient is 0. And here the gradient is approximately maybe 2, whatever. We can read off the y for the x, but we don't want to be reading off a graph. We want to know exactly what the gradient is of this curve at a certain point. And to do that, we use the x.
We're not estimating.
No, we're not. We're finding. So at a particular point, we want to know what the gradient is. All right? We will use the x coordinate. All right? So they will say at x equals 5. Or they might say at the point 2, negative 1. All right? This is what we are substituting in. So if we were doing this one, we'd be putting 2 in for x. So the gradient of that curve at x equals 2 is 4. The gradient of that curve at x equals 5 is 10. All right? So what does the question look like? Find the gradient of f of x equals 5x power 4 plus 3x squared minus 2 at 1, 6. All right. So the point 1, 6 is on this curve. How do I know it's on this curve? What do I do to find out that 1, 6 is on this curve?
Differentiate.
No. How can I test a point is on a curve or a line or anything? If I put 1 in here, what should I get?
6.
6. 1 is 5, plus 3 is 8, minus 2 is 6. That point is on this curve. All right? So this is our question. We need to answer it. This is for our first question in the exam. We will differentiate, because we're very highly likely to have to do that to every single thing we meet in the test. 4 times 5 is 20, x to the power of 3, plus 2 times 3 is 6, x to the power of 1, which I don't write, and the minus 2 vanishes. Happy? Okay. That's the gradient function. It will give me the gradient at any point on that curve I want by substituting the x part of a coordinate. So for 1, 6, I'm only interested in x equals 1. So at x equals 1, f dash of 1 equals, and this will now start to look familiar because we did it the other day, put 1 wherever x is. 20 times 1 cubed plus 6 times 1. 1 cubed is 1, so that's 20 plus the gradient of that curve at x equals 1 is 26. We need to tell them that we know this is the gradient. So it's important to say that that's the gradient. It's important to say that this is the gradient function. All right, it's part of doing it. But that process gives you perhaps 2 starting questions in the exam. At least one will be exactly like that. One could be like that, and one could say at x equals 4. So it's just the 2 different branches of the same question.